is basically in changing, tuning the particle sizes by changing tuning the color by changing the particle sizes. This is an example of smaller and bigger particles. A phosphor material can appear blue to your eyes because of the sizes of the particles. If you increase the particle sizes, you can tune it from blue to red. Similarly, you can have a red particle. If you want to make it smaller, you can change. If you want to change the color, you can make the particle size smaller. So we explain exactly what is happening here, where you have the widening of the band gap, the broadening of the band gap also. The phenomena that is called quantum confinement. So now let's look at the applications of phosphors. We use phosphors in light-emitting devices. For example, you can transform ultraviolet light into visible light, like the light that we have here, fluorescent tubes. There's a lot of science that is involved in here. You have mercury, you have noble gas, you have the cathode ray tube. But what is interesting for us is the phosphor coating, which serves as the source of light inside this tube. Application also in LED lighting. We use phosphors in LED lightings. To get white light, we have to combine these three LEDs, red, green, and blue, together, and now at the end you will get the white light. But what is important for us is that we have a phosphor coating which serves as the source of light inside your LED. Just taking you back to the evolution of television screens, starting with the cathode ray tube, which is, I would say, it's extinct at the moment because we are now looking at flat screens. But the reason why this is extinct is because of high power consumption, poor picture quality, and heavy weight, and it's also less durable. But inside the screen of this, we use phosphors. There are reasons why these screens, this type of television screens are extinct. We also know about the plasma. Remember, not every flat television screen is a plasma. There's a difference. So it's a plasma which made its way to the market in the early 90s. But I think today we are also in the process of phasing it off. We have phosphors in the plasma screen. But now the disadvantages of these compared to LEDs, I'm going to talk about LEDs in this one, it's heavier. It's less bright, it uses more power, and the most drawback of this is it liberates a lot of heat. For those of us who have plasma screens at home, I think in switching in operation, you pass in front of a plasma screen, there's a lot of heat that is liberated. So currently we have LED TVs, which are thin and lightweight compared to plasma. They are very bright and they are highly durable. So these are made up of a variety of, multiplicity of LEDs which serve as a source of light. We have phosphors inside of them. So they give a better performance compared to other versions of TV screens. I will not go through the preparations. We have different methods of preparing these phosphors. One-pot synthesis, sol gel, combustion method. We teach students how to do all this. Characterization, the structure, we look at the broadening of the peak versus the narrow, sharp peaks. Also, we try to understand what is happening at the bottom by changing the shapes and the sizes of your particles. I'm going to talk about the shapes of the particles in my applications to solar cells. What do we do in our research? We try to improve the light emission, the output of the phosphors, because if we have a better light output, it means we can have durable devices. So what we do is we do whatever we want to do to create new types of phosphors, which could be more durable. For example, here you have silica, you have cerium, and then you can look at the output. It's very low compared to this material where you have incorporated zinc oxide nanoparticles. Zinc oxide serves as the sensitizer. You get energy from this transferred to cerium, then you can enhance your material. So we are making different types of phosphors. We improve the light output, which could lead to a better performance and durability of our